Hey guys, welcome back to our channel. Today in this video we're going to be talking about centripetal force. So we're talking about centripetal force, and there's going to be various parts, so I'm just going to talk about part 1, where in this video specifically I'm going to be addressing the horizontal case because there's also the vertical case. So let's focus on the horizontal case. So now, whenever centripetal force is just circle, whenever you're going on a circular motion or trying to do a circular path. I probably could have done a better job with that. Let's try this out. Oh, there we go. Cool. Alright, so now whenever you're trying to go in a circle, you have a radius, or center, right there, radius R. So now, whenever you try to go in a circle, have you ever noticed that if you're driving a car, it's either a freeway or a roundabout, and you're just coming on a straight line, right? You're coming, and then you just decide to turn. Now, have you ever felt that around here, like you feel a force that's pushing you out or so? And you're like, oh man, I'm going to fly out. Well, actually, that force in physics doesn't exist. That force is a result from the centripetal force. Now, the reason why is because Newton's, if you guys remember from our previous videos, first, I'll just abbreviate because we're actually going to prove how all three laws applied for circular motion and centripetal force. So the first law said that all bodies in motion want to stay in motion, and at rest want to stay in rest. And because you have motion here, as soon as your car starts turning, your body wants to fly out and keep going straight. So what your body does, it's following Newton's first law. It wants to keep going the same linear way. And then Newton's first law tells us that unless a force is applied, and that force is right here, which is called the centripetal force. So now this corrects it for here, and this other force that you feel is just a result from our centripetal force because of Newton's third law. Remember, all forces have an equal and opposite reaction in magnitude. So what you feel, which is known as centrifugal force, it's actually not a real force. I'm sorry, guys. Yeah, I know. I was devastated too when I knew about it. However, this right here is called centripetal force. All right? And then, just to keep mentioning this, building it up a little bit more, then when your car turns again and then you want to actually keep flying out this way, your body wants to go in this, keep going on a straight line, and then you have again force of centripetal force. In our case, force of friction, because we gave an example of the freeway or a turnaround. So then this force right here corrects your path to keep going on a circle, and what you feel is the centrifugal force. All right, so now having stated that, there's a lot of math involved and everything to find out the formula, but I'll just give you the answer. A subscript c, which means centripetal, is equals to v squared. This v is linear velocity at which you're coming, for example, before the turn, over the radius. All right, so now remember Newton's second law, which I told you guys that it will come back to haunt you if you didn't know it. Well, here it is again. So I'm just going to say Newton's second, you guys know what else, is equals to F equals ma. Now, this acceleration, if we're moving on a centripetal path or in a circle, the acceleration is the centripetal one. It just ends up being mv squared over r. All right, now, for the most part, if we're talking about a horizontal turn, most of the time this force right here, when you do some of the forces, v squared linear velocity. Acceleration. This F ends up being most of the time the force of friction. So your force of friction is going to be equals to n v squared over r. I'm leaving the vectors out because you guys kind of tedious, so I'm just going to assume you guys remember that. But yeah, this is your formula for most of the time whenever you're talking about a horizontal circular path, whenever you're coming with a motorcycle or a car and you decided to turn. In the next video, I'll actually do an example to show you guys how this applies and how we can find excuse me, how we can find either the maximum velocity that you can go in a circle out of a given radius, or the maximum or minimum coefficient of friction that a surface needs to have in order for you to make that turn, or fly out and just probably die. Hopefully not. But yeah, that's all I have for you guys in this video. Remember, leave us your comments on the section below. Like us on Facebook, like always, and subscribe on YouTube. Thanks, guys.